And we're back. Okay, so part two. So we are still working with some properties of logs. This time we are doing some of the expansion and contraction of logs and writing them as maybe one or maybe writing them as multiple logs. So we get our different rules with this. We get our product rule. And your product rule is just saying if you have the log of two numbers that are being multiplied, we can expand this into multiple logs through addition. So the log base remains the same, and all you're going to do is add the two numbers. Quotient rule, very similar. The only thing is when we split these two up, we are splitting them up through subtraction. Okay, and keep in mind numerator will come first, denominator will come second. And then the power rule, I feel like everybody remembers this one. The power rule just means bring that power out to the front and down. So I would have C log base B of R. Okay, so we're going to practice some of these. So practicing this, and key thing here, some people get this confused. Read the statement and take a look at really what it's saying. It says we're going to write it as a sum of logs or multiple logs. So whenever I'm seeing multiple logs, that means my answer is going to have just exactly what it's saying, more than one word of log written out. If I'm only seeing one, I've done something wrong. So looking at what we have and keeping in mind, notice what that exponent of 4 is going to. 4 is only attached right now to the y value, so think about that as we are expanding. Everything is being multiplied, so we expand multiplications through addition. And it's a log base 10, so you don't have to write 10. You can, but I'm not going to. So we have log of 8. Now I'm going to expand with addition, plus log of x, expand with addition, plus log of y to the 4th. Now we can do one further step here because we do have that exponent, and it was only to the y, so the 4 can come down in front. So we have log of 8 plus log of x plus 4 log y. And now we've expanded. And now again, I can see multiple logs. Okay, different from this next example where it says single logs. So at the end, I have one single log expression. And now again, notice the difference. We're doing natural logs. The rules are the same, whether it's log base 10 or natural log. This is just log base E. Rules are the same. And notice it's saying single log, so that means at the end I should have one log written. If I have more than one, I've done something wrong. Okay, first thing I'm noticing is I have a number, a coefficient in front of a log. And anytime that happens, that's always an exponent. So I'm going to start by bringing up my exponent. So I have natural log, and now because that's grouped as a natural log xy as a group, they both get that exponent of 2. Now, again, trying to get it into a single log, I see subtraction. I know subtraction will compress down to division. So here's how you get your single log. Once I turn it into division, I lose the 2. I have my numerator is from the first term. My denominator is from the second term. And now we can simplify this. Okay, so if I were to simplify this, let's work with the denominator and expand that, so I would have x squared y squared. And now using properties of exponents, when I have exponents that I want to reduce, I'm thinking through division, I'm thinking subtraction with exponents. So x to the 5th over x squared, once I subtract those, I'm left with x cubed in the numerator, y squared in the denominator. I like to think to myself when I'm doing that subtraction, wherever my larger exponent lies, once I subtract, that's where it should be. So my larger exponent was in the numerator. I subtracted 5 and 2, I got 3. I know it should remain in my numerator. Okay. Different type of change of base. Sometimes when you have a change of base, it's maybe not changing the form, but it could be changing it from perhaps log log to a ln natural log, okay? And looking at this, it says when working with a log expression, it's with an undesirable base. So this is what we're talking about, is like that change of base. All right, it's possible to change the expression into a quotient of logs with different bases. So if I want a different base, maybe I'm going from a log base 4 to a log base 10, or log base 4 to a natural log. This is what we're going to do, okay? And we're going to try and take a look at how it works, and then we're going to come up with a nice little simple trick. So first thing is, let's think to ourselves, let's do that base to the power equals the number kind of a conversion like we did on that part 1. So that would give us 4 raised to the y is equal to 7. Now at this point, I could turn this into any log base I want. Natural log base 2, log base 10, doesn't matter. So I'm going to introduce, how about a natural log? And if I do it to one side, I do it to the other. And using our properties, I know that that y is going to come down in the front. So that gives me y, natural log of 4, is equal to the natural log of 7. Notice I've changed that log base maybe into something more desirable. I want to solve for y, so to get y by itself, I'm dividing through by the natural log of 4. And so now I have something that looks like the natural log of 7 over the natural log of 4. So think about where this came from. This is the equivalent expression to log base 4 of 7. So a nice little shortcut I like to think to myself is whatever log base I want, it will be. Okay, log base 10, log base 2, log base whatever. The numerator log comes from the big number, where the denominator log comes from the base. Okay, so if we were to summarize this, so change of base formulas. We could say if I have, I'll give you a couple of different ways to write this, log base b of x, I could turn that into any log that I want, so I'll call it a of x divided by log of a of b. Again, notice numerators coming from that big number, denominators coming from that log base. Okay. I could do the same thing if I wanted it to be a log base 10, right? Because it doesn't matter what log base I have. So I could have log of x over log of b. And like we just did up above, I could do it with natural logs. So if I have that same thing, log base b of x, I have the natural log of x on top over the natural log of b on the bottom. Okay, so if we try and we practice a couple of these. So, and again, you can change it into any log you want. Maybe I want to turn this one into a natural log. Okay, so natural log of the numerator becomes the big number on top. Natural log of the denominator becomes that log base. And then if I wanted to, I could plug it in my calculator and I could get an approximate value, because keep in mind, we can evaluate this now. Okay, this was handy before the Inspires came out, and the Inspires have the nice log base where you can enter in any base. Before that, this would be a nice way that we could actually find a value. Still a nice way to find a value, just a different option. Okay, taking a look at letter B, so same idea. Maybe I want to turn this into log base 10 because I just want to evaluate a regular log. So I could have log base 10 of 10 up on top, and I could have log base 10 of 6 on the bottom. Now keep in mind, this log base 10 of 10, these are inverse operations. So that really would simplify down to 1. And I would have log base 6. So if I were to try and simplify it, that's an option. Again, if I wanted to maybe try and get a value, I could plug that into my calculator and get a numerical value. Okay. Maybe let's try turning one into a natural log. So if I take a look at this, so same idea, log base e, which is your natural log of 2 on top, and on the bottom I'd have natural log of 1/2. Okay, so I can expand that denominator since that's a division problem, and we know division turns into subtraction. So if that turns into subtraction, I'd have natural log of 1 minus the natural log of 2. Now, if we think of our graphs, go back to that part 1. Natural log of 1, that's your x-intercept. Natural log of 1 is 0. So I can simplify this more. So that would give me 0 minus natural log of 2, which is really like saying the natural log of 2 over negative natural log of 2, which really is negative 1. So all of that work, we got to simplify that down to negative 1. So that's using some expanding, contraction, simplifying properties of logs. And again, we'll try a little bit more of this in class. Hope this helped. Have a great day.